Hello guys, today I'm going to show you the simulation of how to do a simulation of I2B and P2B characteristic of PV module using MATLAB software. Yeah, this is a MATLAB software, and today I'm going to show you how to do a simulation of a PV module characteristic. This is the total overview of the PV module here. Here we are using a solar cell instead of a PV module. You can also use a PV array. I'm preferring solar cell more than that PV array because it will be more easier to explain. So let's go, and we will do it step by step with no step skipped, so you can get a clear overview how to do it and what are the components and what are their functions. Thank you. So here we are on the first page. First we will go to the home, and then we will click on simulation library. This is a library. From here you can use all the tools, all the equipments what we want. Yes, and now we will open a new window of our workplace on which we are going to drag all the equipments and make our simulation. We can enlarge it little more further so that we can get a more space for equipments to be shown like this. I am preferring this view because both of the windows are shown simultaneously, so we can easily drag the equipments. So let's start. Okay, the first is we want a solar cell. Solar cell is very important, like solar cell. Here it is, solar cell. We will drag it here. We can also increase its size if you want, but I will prefer like this. Then we will go to sim space, utilities, and there will be an option known as PS simulink and SPS simulink. We will drag it to here. Now what it does is that the amount of irradiance what we want for the solar cell is in a quantity which is a constant. It is not a defined quantity. It is a unitless quantity, and we want it as a physical quantity to be given as an input in a solar cell. So it's very important to convert a unitless quantity into physical quantity. That's why we are using a SPS converter here. Yes, and again we will be needing a constant. Yes, we will be needing a constant here, definitely. We will put it here. We can decrease the size of this because we don't want it to be shown a bigger one. We can align it later. First we have to connect all the equipments. Yes, connect this to this, and again connect here to here. Now as seen here, we are having a constant one. We will change it of course to 1000. Okay. Now the next part is we need a current sensor. Here we are as we can see that this is a current sensor. as the name suggests, it's a simulating device used for sense the current. We will give a output of the solar cell to the input of the current sensor as this. As it is an input output connection, it will give a blue line here. In most of the matlabs in the previous version it will not give, so don't be in any don't be in any don't be in any confusion that how to connect this. So here it is. And now next thing we want to do is we want to again come to that converters, and again we want to convert this physical quantity to again a unitless quantity, because we want to show it in a graph. So again we will drag a p as converter. This time it will convert a physical quantity into unitless quantity again. Now this is done. So our next step will be a voltage sensor. We can also drag a solver configuration here to connect it to the ground. Here it is, fx is equal to 0. We don't need to, as just this is a configuration of on and off, whether the PV module is on or PV module is off. If we are putting at 0, it's on, and when we are putting it as 1, it's off. Just it's simple like this. Now we will connect the ground to this f of s configuration. It's just simple as that. Now we will be needing one more physical to unitless quantity here, so we are dragging this to here, and again SPS here, so we will be dragging it here too. Now what we need is a voltage sensor. It's very important, because after current we want to measure the voltage, and to measure the voltage we need a voltage sensor. Here it is, a voltage sensor, just like that. Now we can change the orientation by pressing Ctrl R, and we can change it like this. It's simple as that. Good. Now what we are going to do is we are going to connect this terminal to this terminal. Negative terminal is going to the voltage sensor like this. Now we need a variable resistor. Bulb resistor. Now we are using a variable resistor here because we want to vary the amount of resistance given to the solar cell, so that we can get a continuous, we can change the value of the loads on the solar cell. So here it is, a variable resistor. Like this. It's just simple as that. As you can see there, it accepts only physical quantity here. So again we will be doing something like this only. We need a ramp. Now what this, it's a type of signal, it's type of a simulate, it's type of a signal which signifies the amount of ever increasing signals from 0 to the amount of time we are making it to increase. It will always increase from 0, and the maximum time will be the amount what we need. Slope will be 1. We will configure it later. Okay, now we will be needing a scope. Now scope is very important because we want to see how it's going on, and what's the value of the ramp, how it's converting it. So in order to see the ramp signal increasing, we need a scope here, and here is where we will be needing a S to PS converter, just like this. We will be connecting S to PS converter from here to here, and then we will be connecting the scope with the ramp signal which is going to the SPS converter, like this. Now here, as we can see that this is a link to the scope from the ramp, so any signals in the ramp will be shown in the scope. This can be also avoided, but in order to see the amount of change in the voltage, how it's going on, we need a scope here. Now we will connect the output of the converter to the input of the variable resistor. Now one terminal of the variable resistor will be connected to the voltmeter gate. Yes, and now we will be needing a ground. Ground is very important because we need to ground the terminal here. So ground is important here to connect. Just connect it here like this, as simple as that. Now the one terminal is connected to the voltmeters gate, and the next terminal will be connected to the ground as like this. Half of the simulation part is done, half is remaining. Now we will be needing another P2S converter here, another P2S converter here, like this, connecting the voltmeters output to this and input, and here the negative sign will be connected to the ground as usual, as we can see this. We will enlarge this because it's becoming little difficult to see the whole simulation, because we will get a whole idea like this. Now we will be needing a graph. We will be needing a sync of XY graph to see the graph between the two. Now here we will be naming it as IV. We want current to voltage graph, I/V. Yes, that will do. Now what we are going to do is we are going to need one more component which is known as product. Here it is. Oh sorry, something is wrong. Okay, I will try it again. Okay, now this is product what we are going to need. We are going to use the current value here okay, and again drag it to here, sorry. Yes, that will do. And the voltage value from here to here, it's as simple as that. Nothing more is required, only this much is required. We will be needing one more connection, which is going to be from here. Okay, oh no, we don't want to increase that much. Yes, and we will be connecting it to the voltage output like this. We can also increase or decrease the size as we want, but here we want to increase the size because it's needed. Now we will be needing another graph. And another graph. As that. Now we can name it as P2I characteristic. It will be shown in this, and here will be shown P2V characteristic. So all the characteristics are here in these three graphs what we are going to simulate here. We will connect the product of P2 V2I to the x-axis like this, and now the I should be connected to the value of I should be connected from here to here. So the I is we are going to connect the I from this point to this point like this. And now we are going to connect the power again. From here to here, and we will be connecting V2 here to here like this. Now we have connected all the equipments and our simulation is ready to be run. The first and foremost thing what we are going to do here is we are going to first check any errors generating in this. As we can see there is no error, so we can go with this running part. So here I am going to run this simulation here. We are going to click this green button, run. It's in compiling. Oh, it's showing some error. I don't know which error it's showing. We will as you can see there was a little error with the irradiance one. So now I'm going to run it again, and these are the three graphs what I have got after running this. This is P2I, this is P2V, and this is I2V. These are the three graphs what gives the characteristic of this solar cell. So this was as simple as that. You can print it also, you can do it again. We can do the same thing by connecting the solar cells in parallel or series, just connecting this panel with another solar cell in parallel or series, and we can also get the characteristic in series in parallel. So this is all for today, friends, and I hope you like this video. It was it was helpful for you. So by this I'm done. Thank you. If you like this video, please subscribe on my channel. Thank you very much. Thank you.